Okay, I think that's it's 33 now. That's probably enough people. Yeah, we'll get started then. Let me just switch over. Cool. So yeah, welcome to what is this? The third workshop of the data science stream for Camp QMIND. I'm back. For those of you who weren't at the first presentation, I presented in the first one, but I'll reintroduce myself quickly. My name's Adam. I'm one of the DODs for QMIND this year. This is my third year at QMIND. Loved it, obviously, or else I wouldn't be coming back for a third year. I guess school-wise, I'm currently finishing up a fifth year in Apple. And let's see, anything else that's relevant? If you want to connect with me on LinkedIn, you can. I don't know. But yeah, today's, or I guess this specific lecture or workshop is all about sourcing data, how to get data for your project, different methods, and sort of approaches that you can take to getting data. Admittedly, this workshop may not be extremely relevant specifically for your QMIND projects, because I think a lot of the PMs have put a lot of effort into actually sourcing your data for your projects throughout the summer. So in this particular project, I mean, some of you might have to do some data sourcing, but a lot of you will have the data ready already. But nevertheless, like, I don't know, it's good to know this stuff. Like, if you ever want to do a project on your own, just like a personal passion project type thing, you should probably know how to get data. I mean, given that it's data science and that's what we're doing, data is kind of important. It's also, yeah, like you need a lot of data as well. I think one fact I have off the top of my head, GPT-3, OpenAI's natural language processing, like their NLP model, it's one of the most powerful models on the planet, and they trained it on 45 terabytes of data. So they had to obviously pull a ton of data from a ton of different places. And 45 terabytes seems like a lot, but each human, I think it's on a day-to-day basis, on average, you're producing, what was it, just under 147 gigabytes of data each day. So I'm not going to quote those. I'm not going to reference those numbers or cite those numbers because I got them off Google. But it's pretty crazy the amount of data that's available to us, and the amount of data that's required for some of these ML projects. So obviously, knowing how to get your hands on those data or on that data is super important, which is what we're going to be talking about today. So for the agenda, we're going to be talking about the methods of sourcing data. This isn't an exhaustive list. I'm sure I've missed some stuff. There'll be pros and cons that I'll talk about of each sort of method that you can use. And then we'll get into a demo, just like the last lecture I did. We'll do just a little bit of a demo in a Jupyter notebook to show off kind of like how sourcing data is sort of easy with some of the stuff we have available to us with Python and some of the libraries. And then obviously, if we have time at the end, we'll do a Q&A. But on to the options for sourcing. So here are a list of, I guess, what I could think of when it comes to methods of sourcing data. There's two sort of broad approaches you could take. You can either download pre-made data sets, or you can make your own data set. When it comes to downloading pre-made data sets, some good places that I've seen or used, Kaggle. Kaggle is a website that hosts data science competitions or machine learning competitions where a company or just an individual will post data, post their data set, a little description about what the data is, and some task that they want you to solve. So it's a good way to find not only data, but also just whole projects you can do. And some companies I've actually seen on job things. I think there was a TD job posting I saw recently, and one of the requirements was a high Kaggle score. So I don't know, looking into Kaggle could be good if you want to pursue a career in data science. Another method you could use to find your own pre-made data sets is Google actually has a data search specific search engine where you can like put in a search query and it will give you data sets related to that query. So if you were looking up COVID data, or you just say COVID-19, it would spit out just a ton of data sets that it could scrape from around the world that are related to COVID-19. Obviously, a lot of research institutions will make some of their data sets publicly available. A great example of this is the MNIST data set. That's actually technically a data set owned by Jan LeCun, who's a researcher, what is he, University of Montreal. If I'm wrong on that, somebody correct me. But I don't know, stuff like that. UCI is also a university in the States that has just a website that has a ton of data sets just there waiting for you to use. And then the last, which I don't know, may not be used by as many QMIND projects specifically, is you can buy data from companies. The reason why this might not be used as much is because obviously companies love squeezing as much money as they can out of you. So purchasing data can often be expensive. Onto making your own data set, there's a couple methods you can use. You can use web scraping, which is something that Levi talked about this morning in our opening presentation. Web scraping is essentially the process of going through the HTML of a website and pulling out information. You could use APIs. APIs are essentially just things that people, or a protocol that somebody has made that lets you access data in some way. It doesn't matter how they manage on the back end or how you end up using it on the front end, as long as it's essentially just providing the connection between getting data from here to there. And then lastly, crowdsourcing data. Similar to purchasing data from companies, this might not be used as much because it's resource intensive and everything, but you can use sensors, interviews, just straight up run-of-the-mill surveys. Those are all some ways you can get data. Now we'll go into the pros and cons though. So I'll start with, what just happened? So we'll start with downloading pre-made data sets, the pros and cons of that generally. Generally, it's inexpensive. That's not always the case. Like I said, with purchasing data from companies, it can get expensive pretty quickly, but a lot of these data sets of these sources I was talking about before, Kaggle, Google Data Search, research institutions, they're all free for the most part. So it can be easy to get started. And some of the places, if they have, I don't know, like tasks already associated with the data sets, it could serve as good inspiration for a different project. Some cons to that, to downloading your own data sets, is they might not specifically fit your needs. Maybe you need a really specific kind of data set with very specific features. You might think your data set has that, but once you download it, it doesn't, and then you kind of have to, you're back at square one. And obviously you have a limited amount of data. Like you only have as much as they're willing to give you. You don't have like a continual source of data going forward. We'll move on to sort of the making your own data sets now. We have our pros and cons of web scraping. So you can pull data from anywhere. That's a big pro. All you need is the website, and you can go into their HTML and pull whatever you want out of it. It's a consistent source of new data with an asterisk there. You can continue, it's a continual source, like you can keep getting data so long as your web scraper is still running. It's kind of free. I don't know, like building a web scraper is free, but it can run you, like you can run into some problems with it that might end up costing you some money. And it's flexible. You can kind of pull data from wherever you want, because at the end of the day, you're the one pulling, or you're the one developing the scraper, so you can make it pull literally whatever you need it to pull. Some of the cons related to web scrapers, they're very, or in my experience, they're very fragile. From what I've seen, unless you're really good with web scrapers, anytime like the HTML like radically changes on a website, your web scraper breaks and you have to build one from the ground up. So if you're working, or if you're pulling data from a very active website that changes its UI every 6 months or so, you're essentially recreating a web scraper every 6 months, which can be kind of tedious and kind of expensive time-wise. Legally, it's kind of in a gray zone. I think Levi was also alluding to this. There are some places and some things where web scraping is just straight up illegal, so we don't condone that. But I don't know, like they haven't really, I don't know what the most recent legislation on it is, but it might be a little sketchy to use. And obviously companies can block your website, but you can also use a VPN. I don't know. These, again, legally in a gray zone, so I don't know if I can actually condone this, but okay, moving on to APIs then. So pros and cons of APIs. Pros, it's a consistent source of data, just like web scrapers. It can be inexpensive for small projects. The reason why I say it can be inexpensive for small projects is because a lot of APIs, especially very popular ones, will have different payment plans depending on how much you're using it. So if you're using it on a development level, where it's just you guys on your QMIND project, you can probably get away with using like the free demo version. But if you're trying to productionalize your model and use something cool, or do something cool on like the scale of millions, you're probably going to have to pay per request or something like that. Also, many APIs are very easy to integrate into just standard Python scripts, and Python also makes it very easy to integrate their libraries or integrate APIs using the requests library, which I'll talk about a little bit later. Some of the cons, I've definitely run into using some APIs with very sketchy documentation that isn't exactly full, so you're left to just guess and check how it works. Same thing with preparing your own data set. The API might not fit your specific needs. You might not be getting the data you want, and that can be a problem. And finally, there are sometimes limits on how much data can be pulled in a specific time period. Like I said, there are payment plans, and a lot of the payment plans, unless you're buying the very top coolest brand, coolest or top premium payment plan, there's going to be a limit on how much you can pull, like monthly or daily or within an hour. So if you really need a lot of data, it might be tricky to use APIs. Lastly, for the pros and cons, we'll talk about crowdsourcing. So crowdsourcing data, pros, the data is tailored as much as you want because you're the one defining how the data is being collected, much like web scraping, but in the real world now. The cons, it's very resource intensive. Obviously, organizing a giant data crowdsourcing effort is really hard and probably requires like an entire division of people behind it. So that's why it's not really realistic for most QMIND projects. It's nice to be aware of because companies do this from time to time, but QMIND probably won't. And the other thing is data will come in slowly, at least slowly relative to like API calls and stuff like that, because people have to go out and actually, collect this data. Some examples of crowdsourcing, you could look at like CAPTCHA or reCAPTCHA. Like, if you've noticed how data is, whenever you have to like do a prove you're not a robot test, they've progressively gotten harder and harder over the last 5 years. That's because they're actually collecting data to then feed to machine learning models, or at least selling to people to train machine learning models, which is kind of interesting. So it's like a fun way to crowdsource data. But now we'll get right into the demo. Now that I've talked about all the pros and cons, I'll show you some of the methods that we can use that I talked about, how they actually work with Python. We can also take a look at some of the pre-made sources, how to get, or what they look like and how to work with them. So yeah, let me just, wrong thing. There we go. Awesome. So yeah, can you guys see the, can you see the Jupyter Notebook? Cool. Awesome. So what we're going to be doing is I just have a Jupyter Notebook that has a couple sections to it with APIs and a web scraper, and we're going to be walking through how to use these APIs and these web scrapers to get just random data that I thought was interesting. If we're interested afterwards, we can take a look at these specific resources for pre-made data. But I think the most interesting thing would be the APIs and the web scrapers. So unless I'm wrong. Cool. So what we have, just before we get started, we're importing some stuff here. So we're going to be importing this thing called Beautiful Soup. Beautiful Soup is a library, one of the most popular web scraping libraries. And what it does is it just allows you to pull HTML data into a variable in your Python script. We're going to be using pandas, which if you watched my first lecture or first workshop, you'll know all about. And we're going to be using this library called requests. For anyone who hasn't used requests before, it is just a library that essentially Python has given you. It comes natively with Python that allows for easy REST API calling. So I'll show you how that works. It's actually very, very straightforward and super easy. This is just because I need an API key, and I don't want you guys to have the API key, so I'm hiding it from you. But essentially what we have here is this API called the News API. What the News API is I think it's made by Google, and it's an API that just scrapes all of Google's, all of the news sources that Google tracks, and it allows you to pull out news articles, information about that news article, and like the content or the body of the news article itself. So it's a great way if your project is dependent on, like, bringing, maybe it's an NLP project and you're dependent on bringing in as many news articles as you can. This API is a great option. Obviously, this is just one example of an API. A lot of things, there are a lot of them out there, but it's one I've used before, so I'm using it in this demo. So what we're doing here is we're making this API client using a key. Generally, this is how they work. An API will give you a key to use to sort of verify that, yes, this is me, I've signed up to use this API, and I'm allowed to start calling things. So this first one, I'm saying news API.get top headlines. So this is just one of the methods that News API has charted up for me, and it's just straight up like, I want the top headlines related to Canada from Google News Canada in English. I said I get that. It returns me a dictionary or a JSON, and I'm just printing it for you guys here. Here are the total results. So we have, I don't know, just the title of the article, the description of the article, URLs to everything, what time it was published, just information about the article. And there are 2 articles in there. Here's another API call we could make. I found this very interesting. Instead of, get top headlines, I'm now saying get everything. Generally with these APIs, what will happen is if it's specifically a REST API, the method will start with either get, put, post, something along those lines. If you look up REST operations, or I don't know, you can kind of see what kind of things they are, but get obviously relates to, I want to receive data. Put and post are related to, I want to send you data. They're all just like standard protocols and standard conventions for interacting with APIs. But here we have get everything related to Canada. Same thing from Google News between September 5th and September 19th. Oddly enough, there were no articles about Canada from Google News Canada between that 2-week span. But I don't know. I'm not one to judge, I guess. And last thing here, just an example. I wanted to get all of the sources that Google is tracking. So I want to see what the News API, which news sources they're actually getting stuff from. And this is a very long list. It outputted just a ton of stuff. I don't know, you could probably scroll through and do this on your own if you were curious, but there's a stupid amount of data sources that it tracks. And lastly, I'm here, this block right here is actually the same, or almost the same API call as the one from the very beginning. So we have top headlines, here get top headlines, except now we're going to be using the requests library. So we have requests here, request.get, and I'm just sending it a URL that will that equates to the same API call that I made at the very beginning. So you can see newsapi.org/ I want to get the top headlines, country equals Canada. Didn't realize that API key was there. That's bad. Yeah, and it publishes all that stuff. And then if I wanted to at the end, I could save this all to a text file. Yeah, great. But that's pretty much it with APIs. That's the gist of it. I mean, once you start working with them, it really comes down to just like interacting with them, and once you do that, it's pretty much the same stuff, just over and over again. Just changes what changes the kind of data you're getting. But we'll move on to the web scraper. So with our web scraper, what I'm going to do here is I'm going to actually use the same requests library, and I'm getting a page here. So what I'm actually doing is I'm retrieving a specific weather forecasting page or web page, because I want to, I don't know, maybe I'm interested in predicting the weather. See if I can do that when nobody else has. What it is being output here is I'm outputting just the page object that I've created. It's outputted a response at 200, which in like HTTP codes, it just means a success. So that just means that my request has gone through successfully. I have data in this page variable. And now I'm using soup or beautiful soup to take page.com, so the contents of the page, and parse it, parse the HTML. Just essentially going through a bunch of, I guess, filtering, and in the end coming up with this tonight variable, which is just, I want the forecast for tonight. And I'm printing it here, and this is the HTML that I'm specifically looking at, that I'm specifically curious in, and I'm going to go even further into it and say I want to find the class period name with a short description and the temperature, so I can print out the day is today, so period name is today, the short description, so this short description here, if we go short description, sunny, and temperature, class temperature, high 81 degrees. So that's what we have out here. So that's one way I could get potentially some data about the temperature. Now I wanted to get some even more stuff. I wanted to get an even bigger description about today. So we can see I'm pulling out a description of an image, and this text is getting pulled out here. Now what we're doing is I'm going to pivot a little bit, and I'm going to be working specifically, I'm not just at tonight, but the next 7 days. I'm sorry if this is like very confusing or you're not following along. I understand that like a big part of web scraping is like sitting there and sifting through the HTML. So I could like go to the web page and walk through with you guys like the HTML and what each aspect of it is. But I think that's kind of dull, so I'm just not doing it. But we have our period tags here, and essentially what I'm doing is I'm looking at the next 7 days. So today, tonight, Sunday, Sunday night, Monday, Monday night, just the next 7, I guess, time periods. And I want to get specifically the text from those. Then I'm kind of using the same sort of code from here, but now I'm getting specifically, the same sort of code as up here, but now I'm doing it for all 7 days, and I'm getting sunny, mostly clear, sunny, partly cloudy. So now I have all this data about what they forecast the weather is going to be like for the next 7 periods, the temperature, and descriptions of even more in-depth descriptions of that data, or of that day. And then in the end, I can use pandas, trusty old pandas, to make a nice clean data frame out of all that stuff, which is great. So now I have all this nice data that I can use to do whatever I want with whatever machine learning or ML model I kind of want to make. That's it for web scrapers, and sort of it for my demo and presentation. This was a little bit of a shorter one. Really appreciate you guys taking a listen. We got some time for Q&A, I think. We got 10 minutes for Q&A. No problem, Rodriguez. I'm glad you enjoyed the presentation. But yeah, you guys are free to ask me any questions about, I don't know, anything. I don't even care if it's about this presentation. It can be about QMIND in general, whatever you feel. If there are no questions, I'm going to head out. and we'll go to the main stage because there's a very cool presentation coming up next. Armand, you got banned by Best Buy? That's funny. Oh, all of UBC. That's hilarious. Geez, good for you guys, I guess. I see. What are some of your experiences with reinforcement learning? So I did my fourth year thesis this past year on a reinforcement learning project. Essentially, what I worked on was we simulated an Amazon warehouse, or as close as we could to an Amazon warehouse, where all of the, it's like the classic, like all of them are robots, and we had all of these boxes and robots, and we had to maximize the throughput of those robots, and we had to get them as many orders out of the warehouse as we could. And we took a reinforcement learning approach to that. So we had like 10 robots, we kind of organized them all. And eventually, I don't know, got some decent results out of it. Nothing exceptional, but it was cool. Learned a lot. And then other than that, it's just been like passion projects and like stuff on the side, like reading papers. DeepMind has a lecture series about reinforcement learning on YouTube for free right now, which I highly recommend if anyone wants to learn about reinforcement learning. DeepMind is Google's like machine learning research group. They're the ones who put out like AlphaZero and everything. Their lecture series was great. I've been watching that. But yeah, other than that, like one thesis project, it's just been like a bunch of passion projects and like reading on my own. Awesome. Yep. Glad I could answer your question. So,
Hello.
where do you find papers? That is a good question, and something that you kind of just like learn along the way. The way that I sort of started was, well, one, in my thesis, I had to read a bunch. But also something that I would just go is, or something I would do is find a professor who's interested in the things. Yes, DVLP. Dennis, that's a great resource. But go to like a professor at Queens or just out of school that does stuff that you're interested in. They all have personal websites or something like that, and just like look at their publications, look at what they've been doing. And if you're not particularly interested in that specific publication or that specific paper, scroll down to the site, like to the references, and oftentimes they'll reference like the most seminal papers of that particular field, and then you can just click on those. And then from there, it's just kind of like a, I don't know, that's kind of where I'd go from it. I'm gonna see if I can try and find it. There was one thing that I saw a few days ago, specifically for CS. We'll see if I can find it. can't seem to find it. I'll post it though, if I can. I'll post it maybe in the general chat. But yeah, if there are no more questions, I think I'm gonna head out. I'm gonna go to the main stage. I think Wendy and Isabel are doing some cool stuff there around EDI and just, I don't know, inclusion at QMIND. So I recommend you all go to that. And then I'll see you guys maybe later.